Hello everyone. Today let's look into how we can create something that moves like an arrow, something that moves like this, you see. Okay, so but first, let's take a quick look on like why arrows move like that, right? So so what we're looking for is let's assume we have a ground. So we're looking for something that moves like that. So it's not only moving alongside a parabolic trajectory, but also it changes its rotation. And it happens because usually arrows, they have a tail, right? And let's see how tail makes the arrow to move like this, I mean changing its rotation. So let's assume arrow moves like arrows facing somewhere above right, and I mean let's assume that for some reason it's moving like not kind of alongside its direction, but a bit sideways. And let's see what will happen with forces acting with this arrow. So of course this arrow is affected by gravitational force. Let's call it force gravitational, and it also affected by drag, by air drag. And this force it's directed the opposite direction of the moving, but for simplicity, the arrow is really sleek along the way, but it has this tail that creates most of the drag. So let's apply the drag force to the tail. And so these forces, like gravitational and drag force, they have different points of like application. So and we can see that they create a momentum that will turn this arrow. So let's start with a blueprint. It would be an actor, of course, because we want to spawn it and so on. Let's call it BP arrow. I already have one, but we are going to create it from the start. Okay, so let's start with just with a box. And make it as a scene root and change so the X will be the forward direction, so we need to scale it alongside Y and X. Y and Z. 0.1 should be fine for our example. So now we have nice arrow. Okay, let's try to place it on our scene. Face it and and hit run. Okay, but of course, I mean, nothing's happening, right? Because we didn't do anything. Now let's enable physics for this object and see what happens now. Yeah, at least it falls down. So we already have one of two forces we need to simulate. And also, I mean, arrows, they usually fly forward because of some impulse applied by the bow. So yeah, let's go to the event graph. Okay, we don't need these events for now. So in the beginning, let's apply an impulse to the arrow. And it's going to be a forward-facing impulse. I don't know, let's try 1000. Okay, it's too small. Yeah, maybe we also want to adjust the mass of the arrow. Let's say 100 grams. Looks like a good arrow. Oof. Yeah, that was huge. Okay, maybe 100 impulse. Oh yeah, it goes sideways for some reason. Yeah, that's interesting. Oh yeah, because the impulse is in world coordinates. Okay. So we need okay, we need rotation, and let's rotate our vector according to the world's rotation of the actor. Okay, now it moves in the right direction. Okay, let's make it 200, just to, yeah, maybe 300. Yeah, just wanted too much with yeah, okay, you see, so it moves along the parabolic trajectory, but it's not rotating. And also a funny thing, an interesting thing, so it moves a bit faster because there is no drag, there is no tail, how to say. Okay, so yeah, let's just add it. And so as we saw from the theory, we just need to add a force to a tail, and the force should be the opposite direction of the velocity the arrow is moving. And yeah, for this I just want to add another box, and let's call it tail. And also, yeah, I just want to make it like zero-dimensional, like a point. And let's move it to where the tail is, where we want to apply our drag force. Okay. And we want to apply this force basically all the time. For that, let's use a tick event. So we want, well, yeah, let's first get our tail and add force. And for force, we need the velocity. Okay, let's get this physics one. Yeah, by the way, it's a nice, yeah, let's get the tail velocity. Should it be okay, right? Because indeed we want the velocity of the tail. Will provide us with a most accurate computation here. And yeah, this velocity is in world space, and this force also world space. So yeah, let's try simply multiplying this by -1. Maybe just linear velocity. Yeah, we don't need the linear velocity at point. Okay, let's include this block into our scheme, our graph. And maybe it's, yeah, we also want a scaling factor. Something like, we don't want our force to be too strong. Okay, let's see. Okay, nothing's changed. Okay, yeah, we just change the physics thingy. First, I just want to check auto weld. Yeah, we have this option enabled. Okay, let's try to do this thing. Okay, nothing happened. Collision enable query physics if you'd like AddForce. Okay. Yeah, it's nice that it's kind of hinting me what to do. I always forgot to apply these settings. Okay, let's go custom. Okay. Yet still nothing, but at least we don't get these strange messages. Let's see what's going on. Okay, tail is here. Well, I probably know what's the problem. So we need to disable physics for the tail, but still keep the collision physics enabled. Yeah, to be honest, I don't know why it works like that. Okay. Now we can see that it's at least slowing down. So the force is applied, tail moves alongside with the body of the arrow, but it's not rotating, and we just need to debug this. Okay, nice. Okay, let's see what we got here. So Hmm. Okay, let's go with something bigger. I don't know, I just want to see how it behaves. Okay. So we're adding force to a tail, and the force is like has the opposite direction to the velocity of the okay, maybe we can yes, see what's going on here. Okay, so okay, so the velocity alongside x is almost 0. That's true, so it's a world velocity. Okay. So yeah, probably the trick is the rotation. So let's try and rotate the vector. Something like that. Maybe it's too small now. Okay, let's apply bigger impulse. Strange. Okay, I don't know. Let's try to just add a force, a random one. facing up. It's still not helping for some reason. I don't know, maybe need a bigger force. Okay. Now it's kind of working, okay. It's going up, 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 but it's not rotating for some reason. Although I added force. Okay, let's try to remove this one. Okay, it's still not rotating. Maybe something with rotation. Strange, 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 strange. Maybe because it's welded, applying the force to the center of mass. Let's try to add okay. Okay, now it's working. Okay, so yeah, now we learned that AddForce adds the force to the center of mass of the whole object if it's a compound object. I mean, I don't know for sure, but it looks like that. Let's simplify then our, and probably we don't need the rotation, but yeah, let's do it step by step. Okay, let's assume we do it without the rotation, like that, and see. Yeah, I think it's a success. It goes very nice and smooth. So let's clean up a little bit, so we don't need the rotation. So, and basically, yeah, let's make it a little bit more reusable. So we need a couple of variables. The first one would be impulse. The second one, yeah, let's call it drag, also float. So we can use drag as our drag coefficient. Yeah, let's make them public, let's say, and set up a default values. Also for the impulse, maybe we can forward. Oh, nice. Maybe we can do something like that. So we can get a forward vector and multiply it by our impulse value. And impulse would be something like 300 by default. Okay, let's verify that everything still works fine. Okay, it works great. And now let's remove our kind of example arrow and play with our arrow a little bit. So let's make a couple of copies and see what we can do with our parameters. Okay, so our parameters should be visible here. Okay, let's try something really slow. Let's go faster, bit by bit. 300 here. Yeah, 400. 500. Okay, I mean, I think it's enough. Okay, let's see how they fly. Yeah, just yeah, now let's focus on the, yeah, so as we can see, the slow ones, they kind of, they are not very good at stabilization, but yeah, that's fair. I mean, the slower the arrow moves, the worse the stabilization. But oops. But I mean, if we want to change that, we have a parameter just for that. Maybe let's remove a couple of, like 1, 0 from here and see how it behaves now. Yeah, it's better. But yeah, it's not very kind of true, because a real arrow wouldn't have that much stabilization at the velocity as slow as this. But if you want that, why not? Okay, so yeah, that was it. Just a final glimpse on the event graph we have. Of course, it can be, I mean, this behavior, it can be made into a component to make it reusable. Yeah, but I mean, for the beginner steps I'm doing, I mean, I think that's fine. I think I can copy paste, and once I am tired of copy pasting this stuff, I will make it a component or something like that. So yeah, thanks for watching. See you soon. Bye bye.